This is the review for the Chapter 5 quiz coming up soon. We'll get started here. First couple things to note. You want to make sure you get out your study guide and follow along with me as I go through this. Pause, stop, and rewind this video anytime you need to. Make sure you go over the sections so you're ready for the quiz. Watch this as many times as you want, just like all the other videos. More times you watch it, the better. That way you make sure you get all the information. The study guide does not have a due date on it, but we do encourage you to do that if you want to do well. You want to make sure you take care of the study guide. If you have questions about it, you can always come and see one of your teachers, and we'd be happy to go over it with you. Of course, take the practice quiz. I encourage you to do that without the study guide because on the actual quiz you won't have the study guide then, so you should practice like you're going to take the actual quiz. And of course, watch those other videos on My Big Campus, especially the ones with the songs. They can help get stuck in your head, which are always a good thing. Finally, study with your parents or a friend or anyone. Have them quiz you on the vocab words, quiz you on the different topics, on all the different things that are on your study guide. Make sure you review with someone. We find that students that review with someone typically do better just because they have someone else that helps hold them accountable. So let's move on then to the actual topics. We're going to start out with vocab words, and you need to know the definition of all these words. The first one is energy, and energy is the ability to do work or cause change. The next one is gravitational potential energy. For gravitational potential energy, that means potential energy related to an object's height. For example, we can see this roller coaster here. The gravitational potential energy is the highest when the coaster is at the highest point. As it falls down, it actually gets a lower level of potential energy because it has less amount of area for it to fall through, and so therefore it means it has less potential energy. Remember, you saw in the equation gravitational potential energy is calculated by its weight times its height, and that's how you can figure that out, is that the higher the number is, of course it has to be higher up because the weight does not change, at least here on Earth. The next one is power. This is the rate at which work is done. Then nuclear energy, which is a type of potential energy that is stored in the nucleus of an atom. And I do encourage you to look over all the other types of energy and just be familiar with them from the types of energy investigation, especially that table at the very beginning. The next ones are kinetic energy, and that's the energy of an object due to its motion. We saw that was 1/2 times mass times velocity squared, or speed squared, and that actually gives us the information for how much kinetic energy an object has. Potential energy, which again is energy that results from the position or shape of the object. And we can see here the baseball being tossed up in the air. Its maximum kinetic energy is near the bottom, and so it's actually due to it moving the fastest, while it reaches its maximum potential energy at the top. But of course, when you throw a ball up in the air and it gets up to the top of its curve before it falls back down, it always slows down. So that means that all that kinetic energy has been changed into potential energy, so we're at the maximum potential and minimum kinetic. As it falls back then to the surface, we start losing potential energy and the kinetic energy increases. You saw this on your roller coaster. You start with a maximum potential energy at the top of the hill, and then as it fell down and rolled down the hills, you increased your kinetic energy at the expense of the potential energy that went down. Mechanical energy is the form of energy associated with the motion, position, or shape of an object, and it is the result of kinetic and potential energy added together. For example, we have the total mechanical energy of the bow. The bow is pulled back and you have elastic potential energy from the string being bent, and then when you release it, the total motion and energy goes into the air, which propels forward, having a high amount of kinetic energy. And finally, work. Work is when you exert a force on an object that causes the object to move. So the object actually is moving forward, backwards, but it is a force on an object causing it to move. Of course, we have the law of conservation of energy, and this is energy can neither be created nor destroyed. And that's a very important concept on there. So as you move the roller coaster around, or as the marble moves on the roller coaster, the energy is not created or destroyed. It's only changing between different types. And so that's what happens with any type of energy transformation that you have. The next topic is to explain how energy, work, and power are related. Since the transfer of energy is work, then the power is the rate at which energy is transferred, and that is the amount of energy transferred in a unit of time. So energy is the ability to do work, and power is how fast we transfer that energy over. You need to explain how to determine an object's mechanical energy. That's pretty simple. It's potential energy plus kinetic energy equals mechanical energy. You add the two together and that gives you its total mechanical energy. And we can see on this example here, we have the mechanical energy of the basketball. And when we look at it, the mechanical energy for A starts out down here. It is 12 plus 10, so that comes out to 22 joules. And we look at it up here, it's 20 plus 2, and that comes out to 22 joules again. Down at the bottom, it has a higher amount of kinetic energy, and it moves up. The basketball slows down up here at the top at the B position, and then when it falls at that point, then of course it has its maximum potential, and its kinetic is at its lowest. As it moves back forward and starts to fall down again, though, the kinetic energy increases. But notice throughout this entire process, the mechanical energy for both situations are the same, and that will be true in every situation. The next one is explain how the different forms of energy are related. As we said with energy transformations in the law of conservation of energy, all forms of energy can be transformed into other forms of energy. And so since they move back and forth between the different forms, and of course it's conserved, that's how we're able to keep the same amount of energy in the system. So for example, light can become chemical, as you can see with the sun growing a carrot. Electrical can become thermal, as you have your stove heating up a pot of water. Chemical can become mechanical. Chemical from the food we eat produces mechanical energy from our movements. And chemical can of course become mechanical in the sense of gasoline burning in a car engine. You need to be able to name and describe the two basic types of energy. And of course those are kinetic and potential energy. As we saw with the types of energy investigation, you guys went through and linked all the different types back to their two basic types of energy. And we talked about it kind of like the square rectangle. How the square is a very specific small type like sound energy, but the rectangle then could be something like kinetic energy. It's a broader one. And we can then go to parallelograms saying that is what energy is. We can relate it back to the concepts we use in math. You need to be able to state the law of conservation of energy. It officially reads that when one form of energy is transformed into another, no energy is lost in the process. So when we change energy from one form to another, energy is never lost. It may seem like it's lost, but you got to remember it could be going into several types of energy, and so that's how it transfers across there. Finally, some questions to take a look at in your book. I encourage you to look at page 175 at questions 1, 2, 3, 5, 6, 7, and 8. Page 176, 12, and 17. And on page 177, 1, 2, 3, 4, and 5. Of course, there are practice quizzes that are posted on My Big Campus that you can check out as well. You can also see us in class, and we'll be happy to answer any questions for you. If you have any questions, again, log on to My Big Campus or ask them in class. Good luck.